Here. In this lab, I'm investigating and documenting the Linux boot process. I'll identify the boot device layout, inspect the kernel and its parameters, and verify the init system. Now, in this scenario, a client reports slow boots. My job is to gather quick, accurate boot info. So I'll start by listing off the block devices to see the disk layout and mount points, and we could do that with the following command. Now, I'm looking for a dedicated boot partition and the root file system. Here we can see a 40 gig disk, a 512 megabyte boot on SDA1, and root is actually on SDA2. Next, I'm going to confirm what's actually in boot. Generally, we're probably going to have the kernel, init RAM file systems, and a configuration file. So let's actually do the following command to see that. And so what you see here is that our typical artifacts include VM Linux for the kernel, init RAM D or init RAM disk .image for our initial RAM disk, and a config file that with the kernel's build time options. Now, to understand how the kernel is being invoked, I'll read the active boot parameters. So I'm going to do this command, and we'll go into the proc directory. Great. So this line shows the kernel. Let me highlight it. Boop, right here. So this line shows the kernel image path, root device, and flags like RO, quiet, or splash. So these options influence early boot behavior and logging verbosity. So now I'm going to grab the metadata for the kernel image to note size and timestamp for the report. So let's do that. So what we could do is stat command boot VM Linux. Great. So this helps correlate boot issues with recent updates. If the kernel was modified just before the problem started, that's a big clue. So finally, I'm going to verify the init system in use. So we could do that by doing the following command. Just a simple ls command, and we're going to use sbin init. All right, great. So if we're looking right, let me just highlight this first. There we go. So on modern distros, this points to the systemd. If you're debugging services and targets, confirming the init system up front saves you a lot of time. Now, in a few commands, I mapped the disk layout, I inspected the boot, captured the active kernel parameters, recorded kernel metadata, and verified the init system. So that's core info that I would need for a quick boot time investigation. Now, next steps would actually be to also review journalctl option B for the last boot and check for the last boot, and to check systemd analyze blame to find slow units. So thanks for watching, and more labs on the way. Take care, folks.